The new airspace is typically low altitude. It can be complex with a lot of different size targets and different speed targets. And it's very difficult for radars that aren't high performance to detect those small drones amidst the urban clutter.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 407. How is cost-cutting radar technology shaping the future of advanced air mobility? For that question, we head to Seattle to speak with Tom Driscoll, CTO and founder of Echodyne, a startup bringing breakthrough radar capability to meet commercial and defense needs across autonomy, security, and intelligence markets. At Echodyne, Tom leads the company's world-class research and development efforts. Prior to Echodyne, he was managing director of the Metamaterials Commercialization Center at Intellectual Ventures, the technology incubator which launched the world's first metamaterials-enabled ventures. Recognized as a technologist, inventor, and entrepreneur with a drive to advance the art of the possible, Tom is a named inventor on over 100 patents, has co-founded 5 startups, and serves on the board of directors of 3. He holds a PhD in physics from the University of California, San Diego, and a Bachelor of Science in Physics from Harvey Mudd, and he's an adjunct professor at Duke University. In this edition of the Drone Radio Show, Tom talks about Echodyne's innovative radar sensors and how they're used in the drone industry, and most notably to support advanced air mobility. But before we hear from Tom, I want to stress that your support is the heartbeat of my podcast. Every episode is crafted with you in mind, and your generous donations ensure I can keep delivering the content you love. Whether it's the price of a coffee or a more substantial contribution, every bit helps to defray the cost of production. Donate today and be a vital part of the podcast's continued journey to greatness. And for a limited time, donate $100 or more and receive an official Drone Radio Show coffee mug. To donate, go to droneradioshow.com/donate. And if you can, please subscribe to the podcast on your favorite platform and leave a nice review and rating on iTunes. It really helps improve the podcast ranking among the many thousands of active podcasts today. So let's learn how modern-day radar sensors are used to advance air mobility systems with Tom Driscoll of Echodyne. Let's pick up the interview where I asked Tom to introduce himself.
I'm Dr. Tom Driscoll. I'm the founder and chief technology officer of Echodyne. Echodyne is a startup company in Seattle, Washington that builds a new type of radar sensor that definitely ties into drones, urban air mobility, and airspace.
Tom, how old is the company?
We'll be 9 years old this December. So I guess at some point, I don't know when you stop calling it a startup company, but we still feel like a startup.
What is the core product or the service of Echodyne?
So the core technology of Echodyne is a new way to build radar systems that are high performance, like the radars that the military has traditionally used, but at dramatically lower cost points and reduced size, weight, and power as well. So we've taken that core technology and we've built it into 4 radar product lines, 2 ground-based radars and 1 airborne radar. And those are being offered for both ground-based and airborne solutions in the airspace.
What differentiates Echodyne from other radar systems?
Yeah, it's really the ability to detect these small drones in complex environments. A lot of radar traditionally, historically, has been about searching for the one fast-moving thing in a big empty airspace. That's the case if you're looking for a cruise missile or an incoming fighter jet. But the new airspace is much different than that. It's typically low altitude. It can be complex with a lot of different size targets and different speed targets. And it's very difficult for radars that aren't high performance to detect those small drones amidst the urban clutter that exists around them.
How are you able to achieve those kinds of results?
What our core technology allows us to do is what's called a phased array radar. That name gets used pretty loosely, but you can think of it almost like a flashlight. And if you've got a new modern flashlight, it'll have a little lens on the end of it. And by turning that lens or pushing and pulling it, you can focus that flashlight into a very tight, narrow beam. And when you do that, you can see further and you can see more clearly. So our core technology allows us to build this phased array radar that focuses our radar beams. It's not flashlight light in this case, but it's radar microwaves. And that focusing just illuminates objects more clearly. And then we can then scan that flashlight pencil beam around a large volume of space and detect everything that's out there.
That's a great analogy. What industries do you primarily serve?
We're intersecting a fairly large number of industries. I'll try to list them. Definitely a major intersection with the defense and military. They are our classic kind of super user of radar. They've been the user of high performance radars all along, and they love that we're offering them high performance at some cost breakthrough. But we're also intersecting with traditional aerospace, some manned general aviation, a lot of intersection with drones, urban air mobility, airspace security. Speaking of security, drones are as much a problem today as they are an opportunity. And so we've got a lot of intersection with traditional security needs that have been turned on their head by drones. Essentially, fences are now useless for the purpose of security. And then we've got a little bit of intersection with ground autonomous vehicles as well, including self-driving.
How do you advocate for the use of Echodyne sensors in the unmanned systems industry?
I'll tell a short story that kind of leads us into that. The very first product we built was an airborne radar for small drones for package delivery. We started building this in 2014, 2015. At that time, Amazon Prime Air was making a lot of buzz, and there were forecasts that the sky was going to darken with drones any year. And so we built a small radar to try to enable that class of drone to fly safely and complete its mission, while not running into anything, not running into ground obstacles and not running into any other aircraft, whether manned or unmanned. And so we built that small radar. But as we all know, package delivery has turned out to be complex, both technically as well as regulatory. And that industry has moved forward, but small steps, cautiously. We now see that the solutions have to be much more nuanced than just putting a radar on every drone. You need control networks that are going to coordinate the location of drones. You need some sensors on these aircraft, but you also need sensors on the ground to spot them. Some of these craft may not even be able to afford a sensor at all. So I'd say our offerings really comprise two classes: onboard airborne sensors and ground-based sensors.
Are the onboard sensors still effective without the ground-based sensors?
Yes, you can do a lot with onboard sensors. The difficulty of the onboard sensor is really their cost. The price points that are needed for small package delivery are very low. It's difficult for them to imagine affording much of anything in the way of sensor. And then also just the weight. Flight is expensive in terms of battery power, and any weight you add to that drone essentially takes away from the package weight that it could deliver. So at the smallest size or the smallest segment, small package delivery, like what Amazon has talked about, I think it's unlikely they've got much in the way of onboard sensors. Probably a couple of cameras, that sort of thing. Cameras are cheap and easy to use. But as you start to move up in weight class, as it were, and talk about medium or large package delivery, like the endeavors of companies like Reliable Robotics and X-Wing, where we're talking about almost Cessna-sized drones or unmanned aircraft, those aircraft, in our view, almost certainly will need to have onboard airborne sensors, including radar.
Is there a typical configuration or a mix of ground-based and onboard sensors?
The viewpoints on that span just about every possible combination. We hear wildly opposing viewpoints from customers and partners, and I think that that's what makes the ecosystem and the industry interesting and also maybe challenging, is that there are a lot of logical viewpoints on the right way to solve this. I think it's going to come down always to a trade. If you have a small number of aircraft or drones that are going to cover large distances, then economically, it's much more sensible to put a really high performance sensor suite on those aircraft and let them take care of the problem themselves. Then if you flip that around and say, at the other end of the ecosystem, I've got places like Amazon Prime Air or UPS or FedEx or Walmart that are going to have fleets of thousands, tens of thousands, maybe eventually hundreds of thousands of very low cost aircraft. It would not be logical to put a sensor on every one of those aircraft. You'd be better off to pay for ground-based sensor networks to help clear the airspace.
How do you help clients determine the right configuration of sensors to deploy?
Yeah, it's a mix of the drone maker, the service provider, and sometimes those can be the same people. You also have oftentimes sort of a UTM or airspace, picture solutions provider. Between the three of them, they're going to decide what feels like the right sensor solutions to enable safe flight. And we're always happy to have a conversation. We never really want to push sensors where they're not valuable. It's not good business long term. We'd rather see this whole industry create right size solutions that move the whole industry forward and unlock the airspace. Because we're talking, tens going towards hundreds of billions of dollars of economic value here. And so we don't need to fight for a percentage point of it early on. We need to help find the right solutions to unlock the whole industry.
What do operators see on radar screens when Echodyne sensors are in use? Is it much different than a typical radar screen?
In the airspace for UTM or AAM, I think it probably looks a lot like if you go to FlightAware and you see airplanes with tail numbers moving across the sky as tracks. That's what a lot of these integrated airspace awareness solutions look like. Our radar outputs tracks as just, a string of information into software that's consumed and displayed on that display as a track with a tail number. In that sense, it's a lot like what air traffic control looks like today, but radar has taken a lot of different display forms. If you look at the display for a radar for a maritime vessel or a bass boat, it looks very different. It looks almost like a Doppler weather display that shows you where there are storm clouds and where there is land. And so the display of radar really depends on the application, I guess is my answer.
The FAA wants to accelerate advanced air mobility, specifically encouraging the development and operation of air taxis. This is a good thing for radar sensor companies, right?
Yeah, I think this is very positive. I'm glad to see us again push on this. It's a lot of inertia to get this opportunity moving forward, and we have to keep pushing on it. In the near term, it's a small opportunity for us in comparison to the business we do intersecting with military and defense. It's a small percentage point. But like I said, it is going to become a very large opportunity, a very large business in 5 years, 10 years, 15 years. And so we're committed to helping invest in enabling that. I'm glad to see the FAA pushing again. I think what we're going to need to see is baby steps and allow organic grassroots solutions to present their own safety cases, because we've got a bit of a chicken and an egg problem. It might be that a ground-based network of radars is the perfect answer for safe flight, but no one's going to pay to create that ground-based network of radars until it's proven that the ground-based network of radars is right and safe, and also until that there are clear requirements that come down for how accurate it has to be, et cetera. So what I think has been the progress that's been most notable is these COAs and Part 107 exceptions and the little baby steps of companies starting to do real operations with real business. Zipline has been a notable success story in that, and we just need to see more of that.
I think the challenge for companies like Echodyne is how and when to decide to make large research investments when the market and the regulations are so uncertain. How do you guys fit into an environment like that?
You have to be willing to go out on a limb. I mean, startups are entrepreneurship. Entrepreneurship is about accepting risk in exchange for the shot at reward. But you also have to manage your bets intelligently. That first airborne radar that we built that I mentioned a little bit ago, there were no clear requirements on, for instance, at what range it had to detect a manned aircraft. So there was nothing that came down from the government and agencies at that point. So we just had conversations with everybody that was a player at that time. And we sort of Venn diagrammed what everybody thought was a good enough range. And that's what we designed around. It takes a couple of years to build a piece of hardware. And so 2 years later, we've got it. We start using it. And the feedback in some cases was, this was great. This is perfect. In some cases, the feedback was, this is not enough range. So you just have to take a bet and hope that you're equal parts lucky and smart.
Is Echodyne partnering with any air taxi or advanced air mobility companies today?
Yeah, absolutely. I would be surprised if there is any serious player in the space today that we are not engaged with in one way or another. Probably a majority of them have purchased some number of our radars and either tested them or have done a complete design integration and are using them regularly. A couple ones worth calling out. We've recently announced a partnership with Supernal that is an endeavor of the Hyundai Motor Group. I think that they've got a lot of very savvy, wise thinking about how to unlock this airspace and the opportunity that it'll enable. So I really am enthusiastic about our partnership with them. And then we've recently joined the One Sky consortium as well. And this is not a single company. It's more of a consortium of like-minded people that want to together help discuss, network, support, and figure out what the answers are to unlock the airspace.
So One Sky is not a commercial entity.
I would call it a support group for people that are still optimistically hoping that this all happens faster than it has been. It's pretty similar to AUVSI, which is the old entity. They've got an air advocacy committee that we're also a part of. So it really is more of a consortium. We jointly discuss what we think should be requirements, should be solutions, and we can, at our own option, jointly advocate those to regulatory bodies, but it doesn't directly create regulation.
Tell us more about the partnership with Supernal. What do they hope to achieve?
Their vision is air taxi, but in stages. And I think like just about everybody, they see this as starting out as almost a piloted electric air helicopter, and then that evolving into less pilots, more automation, more central control, and ultimately a very large network of these solving some really tricky problems in dense and cluttered urban environments with too much traffic. So how far along are they? I think that they announced the formation of the Supernal division or endeavor 3 years ago, but being part of HMG, they can take this long vision, this long bet. They're very well funded, and I think that they've got an aggressive but realistic timeline.
Echodyne sensors are recognized as top of the line, but can they be better?
The work never really ends, I'll say. It's true that our products are in production, they're complete, but we improve them constantly, usually between 2 and 4 times a year through major software releases. So all of the signal processing and artificial intelligence that's inside these radars can be improved, and we do that steadily. So we're always trying to make them better. And that improved performance can be things like longer range, it can be better accuracy, it can be the ability to classify objects as to whether or not that's a small drone or a bird. You probably still want to avoid it, but one of them might incur more damage to your aircraft. And so there's always more work to be done. And radar is a tricky sensing modality. So as you conduct operations, you always find new things that are surprising. Like you might be able to correctly see horizontal power lines and avoid those, but a vertical wire might not show up. And so you have to go back to the drawing board and invent some algorithm to detect vertical wires, because obviously you need to be able to see them both. A good analogy for this might be the work that the self-driving car community has done using mostly cameras. You might ask, what work is there left once you've integrated the camera into the car and you've got your pictures and video? And the answer is there's still a lot of work. You start discovering odd things like a person wearing a shirt or a t-shirt that's got a stop sign on it. The camera sees it as a stop sign. So sensing and perception for autonomy is a long tail problem. The work never ends.
Is there anything specific or unique about the partnership with Supernal that we haven't mentioned?
Yeah, it is public knowledge. They made a joint investment in Echodyne when we raised our last round of capital, our Series C. It was a minority investment, but we took a lot of pride in that out of all of the radar companies out there, and there are a large number of them, they believed in our core technology, our breakthroughs enough that they not only wanted to buy product from us and engage in this joint development program, but they wanted to be an investor in the company as well.
Let's switch gears and talk about the origin of the company. First, what were you doing before Echodyne?
Before Echodyne, I was the managing director of a technology incubator here in Seattle, whose job it was to figure out cool things we could do with this new field of physics called metamaterials. Metamaterials is the way in which we're able to form these phased array beam-forming radars that have that flashlight-like capability. And they do a lot of very cool things for radar. But this physics field can also provide a lot of potential breakthroughs in other areas like optical communication, like cellular communication, potentially in structures and material science. There's really a wide range of applications for this field of physics. And I was here in Seattle running an incubator trying to figure out what we could do with it. We charted about a half dozen good ideas for startup companies, and those have all become startup companies. By my last accounting, created through this incubator $1 billion in investment capital into startup companies and nearly $4 billion of market capitalization.
You had a choice of leading several companies. Why did you decide upon Echodyne?
The radar is really cool, and it's a very deep discipline. I just find that every time I think I understand it pretty well, there's another layer to the onion.
What challenges did you have to overcome in starting the company?
Well, I was lucky enough to have a savvy and seasoned co-founder, our CEO, Evan. And so he sort of brought a lot of business experience and some of the corporate operation experience that I didn't yet have. I brought a vision for the technology and a passion and a technical team. And I think we've been just absolutely fantastic partners in crime, as it were, over the last 9 years. So what challenges did we have? As I look back, I would say, I think we've actually had it pretty good in terms of really serious existential challenges. We've been lucky enough to have a patient and truly deep believer set of investors that have supported us through a couple things that might have killed other startups. I mean, we misread the timing on when drone delivery would happen. That was our first product bet, was that airborne radar for, not just Amazon Prime Air, but all of that ecosystem. And we were wrong by at least 10 years, but we were able to keep going, build some additional products, find good beachheads and good scalable revenue streams in military and defense and security and critical infrastructure. And now we're going to be around when we take this second wave, or maybe it's the third wave, I've lost count, at AAM and UTM and aerospace in general.
Did you start Echodyne with an emphasis on the commercial sector and then move into the military, or was it the other way around?
It was always balanced. We actually wrote down a vision statement pretty early on that talked about the fact that military defense is the savvy, seasoned user of radar, and that we should recognize that and look for opportunities to sell to them. We don't need to convince them that radar is a good sensor or what its advantages are. But we do want to build a commercial company that scales like a commercial company, because that return on investment for all of our investors and stakeholders is traditionally, it's much better economics to have a commercial scale story.
What advice would you give to other entrepreneurs?
First thing, hardware is hard. It should be obvious. It's in the name. So don't underestimate the length of that road, but it is very satisfying when you can hold the thing that you and your team have built in your hands and, turn it around and feel it. And then the second piece of advice would just be, make sure that you believe in what you're doing and you're passionate about it, because it is going to be a lot of work.
What have the last 9 years taught you about the drone industry?
It's taught me that it's really tough to call the coin flip of the unopposable force of the optimism of Silicon Valley versus the immovable object of the regulatory caution, which comes from a good space. I'm not critiquing it, of traditional aerospace. Airplanes need to be 5 nines, 6 nines safe. And that's sort of incompatible with a move fast and break things mentality. But we're working it out. We're figuring out a way to work together and find right size compromises.
What's next for Echodyne?
Yeah, so 6 months to a year, we just started general availability production of our latest product that's a new longer range radar. It speaks primarily to defense and military. We've got a lot of engagement given some world events. There's a lot of interest in it right now. Its primary application is for counter-drone defense. Drones are being used in new and interesting ways that is changing on almost a weekly basis in various conflicts. And so there's a lot of demand for a high performance radar that you can deploy at scale, deploy a lot of them to create air security and air defense networks. But being that this radar is longer range, we also think it's a really great solution to create ground-based radar networks for things like air corridors. And so we're engaged on a number of air corridor programs where these are, like I said, sort of organic grassroots, let's see what we can show works movements to just start with a corridor of 10 kilometers or 50 kilometers, and then later move it to a 100-kilometer corridor where there are ground-based radar networks to deconflict the airspace and ensure safe flight. So that's what's on our plate right now, is rolling out that product availability to more users and more integrators, helping them integrate it into their systems and networks, and then continuing our cadence of software improvements and updates for it.
And for my final question, Tom, what message would you like to leave regarding the future of the drone industry?
I still continue to believe that one day the sky will literally darken with drones. We just have to keep at it. It's going to be really exciting. A three-dimensional world is superior to a two-dimensional one.
That's it for episode 407 of the Drone Radio Show. I hope you enjoyed hearing from Tom Driscoll of Echodyne. I want to thank Tom for taking the time to speak with me. If you want to learn more about Echodyne or want to connect with Tom, check out the webpage at echodyne.com. If you like the Drone Radio Show, please subscribe and share. Write a glowing review on iTunes. And if you're able, donate to keep the podcast going. Go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Gores.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.